now it is time to turn to another of our speakers, turning back from the European Union Agency for the Space Programme. I am now glad to welcome on stage Mr. Antonio Atlasis, I'm so sorry, Head of System Security Engineering Section at the European Space Agency. If you wish, you can go there or have a seat. Thank you.
Good morning, all. First of all, allow me to thank you for the invitation. I'm really happy to be here. Okay, here they are. Okay, good. I will take it one step after the very interesting keynotes and introductions we had today. It has already been expressed very clearly the need to protect space systems, that they constitute part of our critical infrastructure, the flagship programs like Galileo, IRIS². But I would like to emphasize that, of course, their cybersecurity is extremely important, but in our view, we should not forget that cybersecurity is vital for any kind of mission eventually, of course, in a commensurate level. Also for missions that do not necessarily protect potentially classified data, even if they are only even if they are small satellites, even if they are commercial missions. At the end of the day, they need to protect the data for the customers, even up to down to the CubeSat. So the cybersecurity should be applicable, must be applicable for every kind of project, mission, system, no matter how big or small it is. It has been discussed already in the morning, and I believe it was a great introduction, the opening keynote about the secure by design. So I would like to take it from there and to explain what we do at ESA in order to achieve this secure by design approach. Before I go there, I would like to say that on the topic of security for space, in the context of some workshops we have organized with industry, one took place a few weeks ago, the other one took place about a year ago. There was some kind of a poll as well asking the industry if they already receive requests from their customers about introducing security in their space systems. And on the bottom right corner of the slide, you can see that from the scale 1 to 10, at least 18, they marked it between 8 and 10, that they receive requests from customers for introducing security in the space systems. A smaller number between 6 and 10, and a smaller number between 4 to 6. So the need for security is there. Of course, there are different reasons. Also, the legislation that was mentioned, NIS2, etc. But it is also a request coming from the customers of the industry that provide this type of systems. Now, secure by design. What are the advantages? It was mentioned in the morning, but I will wrap up a bit this topic quickly. So, of course, it helps to increase the security posture, but it's not only about that. It also helps to decrease the cost. Okay, it is clear that nothing comes for free, but as mentioned from some of our other speakers, if you introduce security later in the process, then it comes with an additional complex, with an additional cost. So it's better to introduce it from the very beginning and not to have it as some kind of an afterthought. It also minimizes the impact to schedule, a very important parameter in order to have our missions in space at the scheduled time. Now, let's see what is needed to achieve this secure by design. Of course, this is not one factor that influences the success of the secure by design. We need to be a combination, and I will explain a bit briefly how we put them all together in order to achieve this goal. First, of course, security, as mentioned, has to be incorporated in the mission, in the design, from the very, very beginning. This becomes a baseline for ESA missions. In order to facilitate the process and not to reinvent the wheel in every single new mission, you also need to have some security reference architecture that can be tailored based on the specific mission needs. We recognize or we acknowledge that not all the missions are the same. Each one has its own specificities, not only on security requirements, but also on the constraints they face. But when you start from a security reference architecture, you do not need to every time to think about what you need to do, but you take it as a starting point, and then, of course, you tailor it based on the needs. And then, a very important factor is that when you have your security reference architecture tailored based on your mission needs, you need to have ready the products that you will use as industry in order to implement this tailored architecture, the architecture that will eventually fly for your mission. And this is a key aspect in order to have a minimum cost and schedule impact. This is what we call as cybersecurity building blocks. In order to achieve this secure by design approach, first, through the Asia Security Office, we ensure that security is being introduced to new missions from the very beginning, and not only to the flagship ones. Secondly, I would like to mention that already since beginning of 2024, a cross-directorate ESA task force was created in order to establish a disruptive ecosystem and prepare the European ecosystem on three main technology areas, and one of them has been cybersecurity. And this task force identified the security building blocks required to be developed in order to fulfill the security needs of these future space missions. So it has been a thorough approach that has been followed across all the directorates in order to achieve this common goal. Now, there are some important factors in order to ensure this success of this cybersecurity building blocks approach. First and foremost, the full approach needs to be modular. I mentioned before the reference architecture. In order to be able to tailor and then to use off-the-shelf products, apparently there must be some kind of a modular approach. Of course, we are not dreaming. We know that there is no one size that fits all. However, if you have this modular approach and products available of different instances for different functionalities, then you can reuse them and have them ready for the missions to come. These products, of course, must be rely on widely and well-established standards, preferably public or open standards. Having big spoke application does not help. Not only does not help security, but also does not help also commercialization and adoption of the products. So we work, of course, together with other bodies, standardization bodies like CCSDS, to ensure that every single protocol that potentially is designed in order to enhance the security in the missions, this is standardized, widely adopted, so every single industry that will implement the standard will be able to be interoperable with others and also to have better chances in order to use their products in other missions. Of course, we do not work in isolation. We work together with other initiatives that can be complementary to the cybersecurity goals you have. I will give an example. There is an initiative about defining the requirements, the interfaces, etc., for the LEO mid-size platforms called MIND. We work together with them in order to see what is arranged in this context, what are the interfaces that are envisaged to be used, because these interfaces, of course, will have to be used by the products to be developed. And iteration with you, with the European industry, with the researchers, with the other agencies is vital. And this is what we also try to do continuously in order to collect feedback, to hear your voice, and to take your voice and incorporate it in our plans. On the other hand, of course, from our side, our experts provide guidance, provide support. We try to improve the processes to make it faster, because eventually we target to have, as we mentioned, products. We're going to have tangible outcome and not just some form of paperwork. And our target is to have multi-usage, not only for ESA missions, but also for commercial or other applications. So, in this respect, I will give now a bit more emphasis to the products, to the cybersecurity building blocks, that eventually these are, I would say, the kind of Lego blocks that will allow us to build our architecture. So, in ESA, there are different programs. Some of them are generic, some of them are application-specific. I will mention briefly both of them. Later on, we will have more detailed presentation in some of them. Regarding the general technology developments, there are some ESA-driven under the GSTP that foresee the implementation of some building blocks. There are actually two pillars there in element one. There is one of them called the baseline products, the one which we believe that are needed for any type of mission, irrespective of the classification level of the needs, specificities, etc. And this is why we call them baseline products. I will list them a bit in more detail later. And then there is a typical cybersecurity compendium where we include activities or developments that are needed in order to develop a bit further before reaching the products. Something new in this cycle after the last ministerial is some advanced cybersecurity products under the so-called resilience and security package. These are technologies which are advanced, more special, and are envisaged to be used for very special needs. So with these pillars, the plan is to cover all the needs for the basic to the very much advanced. But these are the transversal one. Of course, there are also some application-specific needs. And the best example for this is to mention Atlasis for us and the need for security for SATCOM applications. When there is a need for an application-specific cybersecurity product, these are developed by the corresponding programs. So, for instance, for SATCOM, these are under Atlasis for us. This is some graph that shows a bit the areas, the families of the products you are planning to cover, and based on the three basic or generic transversal pillars that I mentioned. So you can see, I will not mention them one by one. You can see, for instance, that the first one, which is the baseline, supports the protection of the link, of the RF, and the cybersecurity on space and ground. When you go to the second one, it goes a bit deeper. It has more coverage, and of course, the third one, which is the more thorough one, then the more advanced one covers the full chain of the capabilities of the protections that are needed. This is a bit of a zoom of the baseline because I believe it is the most urgent and the most important one in terms of having the baseline security for all missions. This is comprised of 8 developments. 4 of them are related with the ComSec, with the crypto devices or the random number generators that are needed to support some of the crypto devices. There is also about the TransSec, the protection of the RF, and also about some activities which are pure cybersecurity. Some of them were foreseen from the draft EU Space Act or from the NIS 2 that was mentioned also before in the morning. Later, we'll have the Atlasis for us as well activities which are focusing on the SATCOM specific developments. I will not mention this slide in more detail. I would just like to give you a glance of kind of everything. You can see that the technologies are mapped to the 5 pillars of the cybersecurity framework. We have the pillars of identify, protect, detect, respond, and recover. And you can see also some color code there. And the color code depicts which ones are baseline, which are under the compendium, which are the more advanced ones. And you can see that eventually it's brought together in order to have a full coverage of the capabilities. And of course, what will be implemented, what will be used, etc., depends always on the specificities on the missions. Wrapping up. It was mentioned also in the first or in some of the other keynotes. Cybersecurity for space systems is not an option. And this is the case not only for the flagship programs, it is the case for every single space system, for the big US ones to the last CubeSat. A secure by design approach is essential because, of course, it increases the security posture, but also it minimizes cost and schedule impact. So it is also on the interest of the project managers and of the security of the mission owners and implementers. Using a security reference architecture based on cybersecurity building blocks made available off-the-shelf as products will facilitate their adoption by future missions and also will increase the competitiveness of the European industry because they will be able to create products that eventually will be used by future missions. Again, not only ESA, but commercial or other. ESA has identified cybersecurity building blocks to cover all the needs and to, as I mentioned, to have different areas from baseline to compendium to more advanced or to application-specific like ARTES. With this, I would like to thank you very much for your attention. I wish you to enjoy CYSAT.
Thank you very much, Mr. Atlasis, and thank you for the European Space Agency for its continued support. You have mentioned how private stakeholders were also important and, well, had demands when it comes to security in the space industry.